We are stationary process and Markov assumption here, students. So we have discussed that there are set of state variables and observed variables for any given problem. So what is that here? What is next step is to specify the dependency among the variables. So we have to obtain what is the dependency among the variables here. So that we are going to discuss in this stationary process. So what is that here we have to do? Whenever we want to find the dependency among the variables, what is the first step? The order of these variables. Okay, we have to order these variables in natural temporal order. Okay, so if you order these variables in natural temporal order, we will be able to get the compact network so that we will be able to find out the conditional distributions. Okay, so that is the important thing here. So we have to place these orders, place these variables in natural temporal order. Okay. So what is this natural temporal order? So which is the variable that is giving the cost? That variable should be chosen first. The variables which are affected by that cost will be chosen next. Okay. So this type of ordering is called causal order. Okay. So the cause and effect will be discussing which are reason for cause will be considered first. The variables which are affected by that cause will be considered next. So like this, we will be ordering the variables. So this type of ordering is called causal order. So here, what is the problem here is, so we have discussed that environment is changing every time. So what is that here? We will be having infinite number of variables. The set of variables, whatever we are taking here is infinite, unbounded. Because so every time we are measuring the state variable and evidence variables for every instant of time. Yes, sir? So that is why we will be having infinite number of variables here. That is the disadvantage of this. So what is that here we have to do? So we are getting two types of problems here. The first one is because we have infinite number of variables are infinite. So the conditional probability table is also unbounded. We will be having unbounded conditional probability. What is this conditional probability table? This conditional probability table we have to define for each variable in each slice. Okay. So whenever we are drawing the network, we have to write the conditional probability for each and every variable in the network. Okay. Since we have infinite number of variables, the conditional probability will also be infinite because how many variables we have? Every time we are measuring that, every each and every slice of the current we are measuring the variables so that we have variables. So the conditional probability is also infinite here. That is the first problem. What is the next problem here? Whenever we are drawing the network, what is that we have to do here is we need to obtain the parents of each and every variable. Since this network is having unbounded number of variables, what happens here? We will be having unbounded number of parents. Okay, these are the two problems we will be getting in this temporal model. Okay, so what is the first problem? Is we will be having an infinite number of conditional tables for each variable. That is one problem. The second problem is we will be having infinite number of parents because number of variables are also infinite. So to solve this, the first problem is solved by assuming that the changes in the world state are caused by stationary process. Okay. So first problem how we are solving it is solved by assuming that the changes that is environment is changing every time. No? The changes in the environment is caused by a stationary process. Okay. So what is stationary process here is the process of change that is bound by the laws that do not change themselves, change over time. Okay. So here, what is whatever change we are taking is due to the laws here. Okay, so we are using set of laws. Based on laws, change is change will be represented. Here, the environment is not changing by themselves. Okay, so that is called stationary process. So what is how we are solving first problem here? The change in the environment is caused by the stationary process. Okay, so that is the change is represented by the laws. So here environment is not changing by itself. Okay, so like that we are solving the first problem. So if you assume this stationary process, what happens here? We have to specify conditional distribution only for the variables within the representative time slot. Okay. So you no need to represent conditional distribution for all the variables at every time slice. Here we need to represent conditional distribution only for the variables given representative time slot, so that we will be having limited number of conditional probability table. Okay. So like this, we will be solving the first problem. That is, while assuming that the change in the environment is caused by the stationary process. So if you assume that, what happens here, the conditional distribution will be represented for the variables only in the given representative time sequence. Okay. So that you don't have conditional probability. So like that first problem will be solved. The second problem here is each variable is having infinite number of parents. Okay. So this problem is solved by using Markov assumption. So what is that we are doing here? We are taking Markov assumption. Based on that, this problem is solved. So what is Markov assumption here is? Markov assumption is nothing but the current state. So if you take current state, depends on finite history of states. Okay. The current state depends on finite history of consider the complete history. Here we are considering only the finite history of so first that is called Markov process. Okay. So the process satisfying this assumption, that is what the current state depends only on the finite history of states. The process satisfying this assumption is called what? Markov process or Markov chain. What is Markov process or Markov chain? The Markov process or Markov chain is that the current state depends only on finite history of previous states. Current state depends only on finite history of previous states. Okay. So this Markov process or Markov chain comes in different types. There are different types of Markov process and Markov chain. So what is the simplest of this is first order Markov process. So here the first order Markov. What is first order Markov process here is the current state depends only on the previous states. If you take the current state, it is the current state we are measuring the current state. It depends only on this previous state. The previous state is t minus 1. Okay. So this is called first order Markov process. Okay. It does not depend on any of these stages. It depends only on the previous state. That is why it is called first order Markov process. Okay. So in this particular case, what is the conditional independence will be given as probability of xt given. Usually, what is xt? My xt depends on the history of the previous states. Okay, in the first order Markov process, this equation will be replaced with the probability of xt given xt minus 1. That is the current state. Xt is what? The current state depends upon the previous state. What is the previous state? Xt minus 1. Okay. So this is called first order Markov process. Okay. So the first order Markov process is what in first order Markov process, the laws govern how the states evolve over time are contained entirely within the conditional distribution. Okay. How we are getting new state. Okay. How we are getting new state completely depends upon this conditional distribution. Okay. So this representation, that is probability of xt given xt minus 1, is called what? It is called transition model for first order process. Okay, that is probability of xt given xt minus 1 is called transition model for first order Markov process. Okay, now similarly we take second order Markov process. The transition model for second order Markov process is the conditional distribution probability of xt given xt minus 2 xt minus 1. What is xt? Is the current state. So it depends upon the previous two states. In the first order, what is that? The current state depends only on the previous state. Okay. In the second order Markov process, the current state depends upon the previous two states. Okay, that is xt minus 2 and xt minus 1. Okay. So if you just see the Bayesian network for first order Markov process and second order Markov process. So this is the Bayesian network. No, all of you see this slide. Okay. So here if you observe xt minus 1 depends upon xt minus 2. xt depends upon xt minus 1. xt plus 1 depends upon xt. That is the present state. This is the present state depends upon the previous state. This is called transition model for first order Markov process. Okay. And second order Markov process, all of you see this slide, all of you say this is the current state. xt is the current state. What are the inputs we are getting to xt now? xt minus 1, and you see here there is one more input, that is xt minus 2 to xt minus 1. Okay, these are the two inputs we are getting. Is the current state xt depends upon xt minus 1 and xt minus 2. Okay, this figure, this is called the transition model for second order Markov process. Okay, that is called transition model for second order Markov process. Okay, so here what is that we are doing? Xt is what? Xt is the state variable. Okay, and these are the parents. We have discussed that if we are taking any variable, the conditional probability is given that the conditional probability of any variable depends upon its parents. In the case of second order, it is having two parents. Okay, in the case of first order Markov process, it is having only one parent. Xt depends upon xt minus 1. Okay. So this is the this way of representation. This probability is called the transition model. So this is the transition model for first order process. This is the transition model for second order process. Okay. So what is that here we are doing? We are restricting the parents of state variable. Xt is what? The state variable. So now instead of restricting the parents of state variable, we will also restrict the parents of evidence variable. Okay. So what is the state variable? Unobserved random variables are called state variables. Observed random variables are called evidence variables. Okay. Now what is that we are doing? We are restricting the parents of evidence variables. Okay. Now for example, if you want to find out the conditional probability with respect to evidence variable, here probability of xt depends upon the state variables till that time and the evidence variables from 0 to t minus 1. Okay, this is the conditional probability for evidence variable. Okay, so what is that we are doing? We are restricting the parents of evidence variable. Instead of taking all the state variables from 0 to t, what is that we do? We are restricting the parent of evidence variable. Now, what is the parent of evidence variable is the state variable xt. Et is the evidence variable. So, this equation, this is the equation that gives the conditional probability of evidence variable considering all the state variables and all the history of evidence variables. Now, instead of taking all these conditions, what is that we do? We restrict the parent of evidence variable, that is probability of Et given xt. Okay. So this conditional distribution, that is probability of Et given xt, is called what? The sensor model or observation model. So that is called sensor model or observation model. Okay. So what is the sensor model and the observation model is that the evidence variables are affected by the actual state of the world. If you are taking ET is the evidence variable at the time T, it is affected by what? The actual state variable or at that time. Okay. So what is this way of representation is called sensor model or observed model. Okay. So now if you see this, this is the sensor model figure students. All of you just see this slide. Okay. So you have to remember this figures. These are very simple figures. See that U is the evidence variable now. R is the state variable. Okay. R represents rain. U represents umbrella. Okay. So whenever you see umbrella, what is that indicates? There is a rain on that day. Okay. Whenever director is carrying umbrella means what? There is a rain on that day or outside. Okay. The security guard comes to know that there is a rain on outside. Okay. Because he is having only this is the evidence to know the weather outside. That is umbrella is the only the evidence to know the weather outside. Okay. Now, if you observe this here, we have discussed that what is this first upper part of figure now. The upper part of figure is called transition model. So this lower part of the figure is called observation model. Okay, that is the evidence variable depends upon the state variable. Okay. So if you just see this figure, see here, if the rain on yesterday is true, what is the probability that the rain, there is a rain today is 0.7. If rain on yesterday is false, if the rain on yesterday is false, what is the probability of getting rain today is 0.3 is the rain today. Okay. So that is the probability of getting rain today depends on the rain on yesterday. Okay. And we also discussed that the evidence variable depends upon the current state. Okay. Whenever there is a rain, then only you can see the umbrella. If the rain is true, the rain is true, then the getting umbrella. Okay, probability of getting umbrella is 0.9. If there is no rain, the rain is false. Probability of getting umbrella is 0.2. Okay, so the probability of rain depends upon the sea. The probability of getting umbrella depends upon the rain. Okay, so here we have discussed the what is this called transition model. Upper part of this figure is called transition model. The lower part of the figure is called observation model. Okay. So from the transition model, we will be getting what the rain today depends upon rain on yesterday. From the observation model, we got that the getting umbrella today depends upon the rain that day. Okay. If there is a rain, you will be getting umbrella. Otherwise, there is no umbrella. Okay. So, other than these two, we have discussed the transition model and sensor model. Sensor model or observation model both are same. Okay. So, in addition to transition model and sensor model, we need to specify what is that unconditional probability. Clear probability is what? Unconditional probability over the states at time t is equal to 0. That is probability of x of 0. So what is the probability of state variable at time t is equal to 0? Also we need to know. Okay, once we know all these three, what are these things we have known? That is unconditional probability of the states at time t is equal to 0. That is probability of x of 0. And what is that? Next we have the transition model and observation model. Once we know all this, we can obtain the complete joint distribution. So what is the complete joint distribution formula? Probability of x0, x1, so on, xt, e1, e2, so on, e2. So in the previous class, we have discussed that the state variables will start from t is equal to 0. The evidence variable will start from t is equal to 1. So probability of x0, x1, so on, xt, e1, e2, so on, e2. This is the joint distribution, complete joint distribution over all the variables can be obtained by, this is the equation. What is the equation? P of x of 0. Okay, still time p we are taking note, so that is why product of I is equal to 1 to p. This is the transition model, and this is the observation or sensor model. Okay, so the product of transition model and sensor model. So this equation gives you what? The complete joint distribution over all the variables. Okay, so this is about the stationary process and Markov assumption. Okay.